Hi, my name is Jaja, and together with my teammate Rana and Rahul, this is our project for the Big Data Analytics course at Columbia University, taught by Professor Qingyong Lin from IBM Research. So our project is about recipe generation based on ingredient network. We came up with this idea because there could be some situations in life when, for example, you invited a couple of friends to come over for dinner and you feel like some seafood, but you don't know what kind of ingredients would go well with it, right? Or it could be the case when you're shopping at a grocery store and you forgot to bring the shopping list with you. You're looking at a pumpkin, but you don't know what else you should buy with it to make a delicious dessert or meal. So we created this recipe generator for you, which can also be used as a grocery shopping assistant. The result we want to be able to achieve is that for whatever ingredients the user are thinking about, we can immediately generate a reasonable combination of ingredients for the user, which can also be viewed as a simple recipe solution. The dataset we're using are obtained from allrecipes.com, which is one of the most popular websites for food lovers. And the process took us 1 week to get 28,000 recipes by web scraping. Each recipe contains information about recipe ID, title, user ratings, and the number of people who have made it, indicating the popularity of that recipe, and also a simple description of the ingredients. We are very selective about the recipes, so only recipes with at least 5 user ratings were selected for further processing. The tools we use for this project are Python, which we use for web scraping, and data cleaning and some text processing using the NLP package, NLTK. We store our recipes on MongoDB, and we also use Spark to do part of the data pre-processing, and we trained a recipe prediction model using Spark's EMBLA library, and we use R as well to do network analysis, and finally Gephi for network visualization. This is the flow chart for our project. So after we obtained the clean data set, we constructed an ingredient network from the data, and we also extracted network features such as centralities and community information as our feature set for the rating prediction model that we trained using Spark. On the other end, we take user input, so user can type in whatever ingredients they want, and we will generate several sets of combinations based on the network as our candidate recipes. These candidates will then be evaluated by the rating prediction model. If they are able to achieve a high rating, then they will be suggested to the user. In the pre-processing phase, we are trying to identify ingredient information from raw text, which typically looks like 1 pound flat steak, thinly sliced, for example. And the method we use is remove irrelevant words from the text based on their part of speech tagging. So we remove quantifiers, units, and also verbs, adverbs. So the final result will look like just flag steak. We also did some manual review to correct some misspellings and also remove irrelevant nouns such as skewer, container, etc. To construct the ingredient network, we selected about 2,000 most popular ingredients which have appeared at least 3 times among all the recipes as our nodes for the network. And for the edges, we basically computed the point-wise mutual information among ingredient pairs So if the PMI between two ingredients exceeds a threshold of 0.3, then an edge is formed. And we also weight the edges by their PMI values. The next step is the network feature extraction. So first of all, we extracted the centrality features from the network. We did eigenvector centrality and betweenness centrality, which represent the popularity of each ingredient. We also studied the relationship between ingredients using the latent semantic analysis with singular value decomposition of the PMI matrix we obtained earlier. And we also ran a community detection algorithm to do network clustering. And we found two major clusters in the network. One has all the ingredients for sweets, and the other has ingredients for savory dishes. To generate new recipes for users, we first divided user input into two types. One is usual combination, and the other is novel combination. So for usual combination, it could be, for example, an onion, which is commonly seen in our daily life. So for this type, we just randomly select a clique that containing both ingredients at the same time, and the new recipe will just be all the nodes from that clique. And for novel combinations such as beef and orange, we were trying to find all the nodes that can bridge the gap between beef and orange. And in this example, A and C. So we randomly pick a mid node, let's say vinegar, and we will try to find a clique that containing vinegar and beef at the same time. And finally, we append orange to that clique to form a new recipe. This procedure will be repeated multiple times to generate several candidate recipes. These candidate recipes are then be evaluated using a rating prediction model, which was trained using stochastic gradient boosted trees and Spark based on the network features. And the optimal number of features we found was 50, which gives us the lowest RMSE of only 0.38. So if a candidate recipe is able to surpass a rating of 4.3 out of 5, then it will be recommended to the user. Okay, this is a quick demo of our recipe generator. So the users will be first asked to input the ingredients they would like to have in the recipe. So let's say we want maybe salmon and lemon. Press enter and just wait a few seconds and we will show up. Okay, fresh lemon juice or lemon, lime zest, cold butter, sea salt, and salmon. Do you like this recipe? Well, maybe I don't like butter, so I will say no. And it will generate another set of recipe for you. And well, it looks good to me. It could be a salad, or it could also be a salmon steak. Yeah, if you like it, and it will ask you to try something else, and if you say yes, and maybe we can try some unusual combination. For example, how about curry and salmon? That's pretty weird. And if the word you input is kind of ambiguous, then it will double check with you. So curry powder, yes. This will take a little bit longer, but yeah, just the result will come out in a few seconds. Okay. So cilantro, ginger, peanut oil, coriander, garlic, rice, curry, and salmon. Well, sounds pretty good. So in this case, since the combination is not very common, it will try to find all the ingredients that can bridge the gap between curry and salmon. So if you like this recipe, say yes. And wanted you to try anything else? No. Yeah, and that's pretty much it. We hope you like this recipe, and thanks for watching.